I'll bring up the school menu. Then it's departments and tech and career ed in the second one. There you go. And here we go. All right, so we finished the green sheet, and now we're moving on to the second one, or the next sort of set of things, and it is the miniature train project, which you are going to make much more advanced part features. And then we also are going to do what's called an assembly, which is where you put a bunch of parts together. And bigger. Okay, so we're going to make each of these parts as individual part files, and then we are going to do an assembly like this. And actually, there is going to be some sort of animation where the train actually moves and everything moves, not like that, but like the wheels actually turn and the whole thing will go down the line. Okay, and the document that we're using for the miniature train is a PDF that is available on the calendar spreadsheet here with miniature train working drawings, which are technical drawings, which is this document here, which is what I'm going to be drawing on during the thing. Okay, so this is what I'm going to be working from here. If you'd like a tangible printout, I can make that, but it's like going to be 2 or 3 sheets of paper. So I'm not going to make a class set, but if you'd like one, let me know at the end of class and I'll start printing a couple of packets out. And the same thing is going to be as before, where we'll have replays, recording, and such. Okay, so let's go ahead and get started. Feel free to open up this document from the calendar spreadsheet just to have something to scroll through. But you can see there are, is it 9 or 10 parts? 9 parts plus there's a piece of track at the end. Piece of train track. So it's really 10 different parts. And yes, there's going to be 4 wheels and 2 linkage arms and so on. You only need to make that part once. And when you go to the assembly, you just place 4 of them. So there's that. And we're going to use, for a lot of these, we're going to use a part feature called a revolve, which is the second most common to an extrude, but still we extrude 100 times more than all the rest combined. But the second most common one is a revolve. And I'll show you a real basic revolve here. I start a new part file. Let's say I have a shape like, let's just make a random closed loop. Like if I have a shape like this, and I do what we're familiar with, which is extrude, you know what it's going to look like. It's going to look like this shape, but like pushed through a toothpaste tube, or like a Play-Doh extruder, which is what those things are called. It'll make that shape. But if we use the revolve, we choose it like we're going to extrude, but then we choose an axis as a second thing. It will spin around it and make the shape that way. But the key is, for a revolve, is any of the horizontal distances get doubled. Okay, so if we spin around this way, it's going to look like that, where what's important is that, okay, if we want our finished thing to be an inch tall or whatever, it'll be that tall. But if we want the width of the whole thing to be a certain thing, we would need to double it. And I'll walk you through this. If we made this 0.5 and did a revolve, it would then be 1 inch sideways. Okay, so it's still 1 inch tall, but it doubles as it revolves. Okay, and we're going to make all of our revolves planning with the revolve axis to be centered and vertical, but you can revolve around any edge. Like that shape would make that type of revolve, and so on. Okay, so we are actually going to use the revolve tool to do like at least half of these. But today we're going to start with, there are 3 different parts. 3 of the parts are some sort of peg, and they have similar properties. The first one we're going to make is the hitch peg. And for the hitch peg, the sketch that you make is just this cross section. And if you make this cross section and then revolve it around the center axis, it'll make the entire shape. Okay, the finished thing is 0.65 tall, and the finished thing is 0.25 in diameter. So that means when we make our sketch, the vertical line is going to be 0.65, but this line is going to be 0.25 divided by 2. This line is going to be 0.5 tall. And this line is actually, it's a little tricky because this 0.4 is the distance all the way across. So it's going to be 0.2. But either way, horizontal distances are cut in half because they are redoubled when you revolve. Okay, so let's take a look at hitch peg. It looks like that. And we'll go like, I need a little bit smaller, which means I can go a little bit smaller this way. Sorry, indulge me. And let's go ahead and sketch, new sketch. And as usual, it doesn't really matter which plane you start on, but we're kind of starting on the front. So I swear I made a new one. Did I? Is that the same new one? Or am I looking at it? Okay. So start a sketch on the XY plane just because. And we'll start with our vertical axis. So from the origin, just go straight up. And right click OK. And like I said before, all of our revolves, we're going to plan by sketching, like taking note of what we're going to end up spinning around. Are you having a technical issue? All right, so we're going to do all of our sketch. We're going to plan based on what axis we're going to revolve around, because that's everything. And so this first line, it's still the issues with line where you make a line, dimension it, make a line, dimension it. And the one that we're drawing right here is the center axis, which is 0.65 tall. So let's go ahead and dimension that to 0.65. And whatever size that ends up being for you. And let's go like this. And as per always. Okay. And as we work our way around the shape, we've got a vertical line is 0.65. And then we need to make this line, like I said, is if the whole thing is 0.25 across the this part of the peg, then this line needs to be half of that. So you can literally type in 0.25 divided by 2, or you could know that it's 0.125. But either way, a line across the bottom. And dimension this 0.25/2 or 0.125. All right, then we're going to work our way around. We've got this, we've got this. We just need a vertical line that's 0.5. So a line from here straight up. And I'm just going to, before I click to set it, as long as it's snapped to vertical, I can just type 0.5 and it'll make that line. What's up? The first line is 0.65. 0.125. This is 0.65. And this one is 0.125. And this one is 0.5. And if you get the working drawings out, you can jump over to it. But I'm happy to answer those questions because it means you guys are doing the right thing. Okay, then I'm going to put this. Normally, I'd put dimensions outside of the object, but the next line I'm going to draw is like directly on top of this. So I'm actually going to move this over, which if you have the dimension tool and try to move it, it will give you the edit dimension. So you need to either hit escape or right click OK or right click escape, and then you can drag it out of the way. You don't technically have to because extension lines and dimension lines and dimensions aren't actually there the way that these lines are actually there. So you could draw on top of it, but like I said, it gets kind of crowded. And so the next line, like I said, is this line. And we know it goes right here, but we don't know the length of this line. What we do know is that it's 0.4 all the way across. And so when we have our finished peg, the distance all the way across is 0.4, which means the distance from the center to this edge to this point is 0.2, which is not the length. We aren't dimensioning the length of this line to 0.2. We're dimensioning the distance from the end of it to the center axis. So it's going to be another 3-click situation. So we need a line, snap to this end, and just make it horizontal and make it about the right size. Get the dimension tool, and we're dimensioning the end point of that line as the first click, and the center point as the center axis as the second click. And the next part of our drawing is going to be up here. So just based on experience, I'm going to put it right there. And that is going to be 0.2. Okay. Again, the 0.2 is not the length of the line. It's the, although you could math it. It's the distance from this endpoint to the center so that it ends up being 0.4. And then the only other line of this is an arc. And this arc, it says SR 0.208. That's spherical radius. Easy for me to say. But that also just means that's the radius of the arc. And so this is going to be your first arc, probably, or your first intentional arc. It's 3 types of arc, 3-point, tangent, and center. We are going to use 3-point almost always, which is also why it's the default. And the 3 points you need to click are one endpoint of the arc, the other endpoint of the arc, and then the third click is how arcy. And for arcs, the general idea is that you always want to set it to make it look right, because right here, if you recall, our dimension is 0.208. So it'd be dimension 0.208. That's correct if you were to make your arc like past diameter, past radius, like past this way, I can dimension it to 0.208, which is the correct dimension, but clearly that's not the right shape. Okay, so, and also if you make the arc to start in the wrong direction and type 0.208, it will still be wrong. And this is why arcs are finicky and a pain. Okay, and so as long as it's going in the right direction roughly and not too far, the dimension is 0.208. And then we just need to do our revolve. Okay, so we'll finish sketch, revolve. Okay, so the dimension of this line, is that what you're asking? It's not the dimension of that line, it's the distance between the end of the line and the center axis. Okay, do you see where those dimensions are pointing? From that point to there. Okay, so we'll finish sketch. Oh, it's 0.2 from the end point to the center. Sorry. And okay, so now we just need to revolve. There's only one closed loop, so we don't have to choose the profile. We do need to choose what axis, which is going to be the center axis that we plan. Okay, again, you can, the shape is not limited to like, if this was the shape we wanted, we would just choose this bottom edge as the rotation axis. And actually, you can have it offset, but we'll get to that later. And so revolve around the center axis and hit OK. Now, we're going to have several parts and the assembly and other things that are all related to this. So you should probably have a consistent naming convention like train, and this one is called the hitch peg. Or mini train or toy train, but something where it starts with the same word or letter, so that when you sort, you can sort alphabetically. And that's good. What's up? What's that? The arc is, you said, can you get help on the arc? Okay. So you are up to this point. You have all the other parts except the arc. Okay, well, at this point, which I think you may be past, 3-point arc tool, which is the default. First click on the top endpoint here, second click on the other endpoint here, make it look slightly arced in this direction, and then dimension the actual arc to 0.208. Okay, and finish sketch and revolve, which is where we are now. Hit OK, and like I said, consistent naming convention is a good idea. Okay, and our goal is to knock out all 3 of the pegs today. Okay, so that's hitch peg. Hitch peg we just did, which is the tiny bit that goes in the back, which theoretically, I guess, could be a magnet if it was a real toy and you had other parts. Okay, so the 2 other pegs are axle peg, which is actually different because we don't get the same cross-section drawing that we're used to after one part. But the other peg, which is linkage peg, which is super tiny, it's the peg that goes like through the linkage arm. It's called the linkage peg, goes through the linkage arm and into the wheel, and it lets them connect. Okay. Its role in the final assembly is kind of irrelevant, but we will knock it out either way. Okay, so we're gonna do this one next, which theoretically should be very identical. What's up? What do you got? Okay, so the linkage peg, we're going to start with the same idea, focused on the axis that we're going to revolve around and build off of that. So new sketch on XY plane, and we'll start with a new line from origin straight up. Now, what is the dimension? Okay, the vertical dimension of our first center axis is 0.325, which is, what is that, 3/8? Doesn't really matter. 0.325. Yeah, save it and call it something like train hitch peg or something like that, or mini train hitch peg or something like that. But just name them all the same start so that you can sort them. Okay, then we're working our way around the outside. We've got this line. The next line we need is this short line here. But again, this dimension, it's the diameter. I haven't pointed this out before. I should have. This symbol right here means diameter, which is sort of the null symbol for other things. But then it's a diameter, meaning the entire distance around this cylinder. But we are only interested in this short line, which is going to be half of that, which 0.0625 divided by 2 is 0.03125. It doesn't really matter. This first one here, 0.325. Okay, so this small one here, that's not what I want. D for dimension. 0.0625/2, which is 0.32. Oh, well, whatever. It's just typed in. Okay, so that is the way that works. This is 0.0625 divided by 2. 0.03125, but that's fine. And in my goal of making things more easy to see, that's not an improvement. Wow, this projector. Horrible. It is kind of unreadable. Okay, so am I talking? Good. The next part is the other vertical line. That's going to be the outside of the main cylinder. And this one is just 0.25 straight up. What's up? The little one? 0.0625/2 divided by 2. Okay, so we need this, what will be the outside, and that dimension is 0.25. Okay, and this drawing is actually missing a dimension, and it's not critical, but if you recall from the other one, it said it was 0.4, diameter 0.4 to the entire edge. So it was 0.4 all the way across. There's no equivalent dimension for this. So we are just going to draw a line that looks roughly correct, then do our arc with the dimension they give us. But we're just going to kind of eyeball this one, which is unfortunate, but it is what it is. Okay, so we'll just get a line that looks about right, which is from this endpoint and straight horizontal, something like that. Right click, okay. And then our 3-point arc again. First click on the top, second click on the endpoint here, and make it look slightly in the right direction. Always making it look as close as you can. And this dimension is 0.1562. And as long as the length of this horizontal line doesn't make the arc look like it goes up, like if we had, even though we don't know the distance between here and the center, which is what we should know, If you go out past a certain distance, the revolve makes it like a little dimple because this, don't do it yet, because it goes up, or the way I just had it goes up before it, do we show sketch? Visibility. Okay, because it goes up first, it will make that dimple, so don't do that. Okay, we want the distance out, and you can actually leave it unconstrained just so that it doesn't go up first, which my guess is it's some sort of regular dimension, but whatever. That looks about right. Let's finish sketch. I'm going to turn off the visibility on this because we don't need it. And yeah, so it's just another revolve. For which part? The line that connects what? The arc? This part right here? Or the height? The height is 0.25 for this outside portion. Wow. Who did that happen to? Yep. Okay. Hit cancel. Right click on sketch one in your browser bar. Down. Yeah, that. And right click and do edit sketch. Right click on the word sketch one. Right click. Edit sketch. It's like third or fourth at the top. Okay. And grab that endpoint. Yeah, and drag that closer. Yeah, just drag it closer. You grab and drag that. Try to get that way. Yeah, that's right there. And then finish sketch with the black. That's the one you have to the arc just, it won't be fully constrained, but just sort of make it look right. This is called linkage peg. So you'll want to say it as train or mini train or whatever. Linkage, Linkage. Yeah, right there. Linkage peg. And okay, so where was I? I was right here. And I'm gonna make it that big and finish sketch, revolve, choose our center axis and hit OK. All right, so we'll save that. And again, train, I don't know, linkage peg, something like that. Okay, and then the third one for today and the last one for this recording is going to be the axle peg, which the axle peg is a little trickier. Like I said, we don't get the basic cross section that we're used to, but that is what we're going to draw. We're going to convert this into a cross section equivalent and then do our revolve. So we just need to figure out what the total height is. What is half of the width of the cylinder, what the height out the outside is, and just sort of based on these dimensions, we'll be able to do that. Okay, first, our first line is, first let's go ahead and start a part because we're going to come in with some numbers. So let's get ready. And we'll save the sketch. We don't know yet. All right, so like I said, the first line of our situation is going to be our center axis, and we want to know its total height. Okay, so we need to break down some of these technical terms. Okay, first one is this part here. 1/4 20 UNC by 1/4 inch offset. Okay, 1/4 is the diameter here. 20 UNC has to do with the thread pitch and rate size. We're not worried about that. One is the length of this threaded part and not threaded part, like everything below the head of the peg, is 1 inch, and 1/4 inch offset means 1/4 of that is not thread. So we can ignore this for now and this. Okay. What we know is that if this is the shape we're looking for, this dimension right here is half of our 1/4 because we want it to be 1/4 all the way across. And our total height is the length of this, which is 1 inch, and that'll get us up to here. And the last part, the head part, which is the remainder, is a distance of 0.125. Okay, if you can see these extension lines, this extension line is measuring to sort of the start of the peg head. Then this part is like the distance between here and here is the size of the flat part. And if you follow this 0.125, this is its corresponding dimension arrow, and you can follow that along. It's the top of the entire surface. So after all that, we have figured out that the total height is 1 inch plus 0.125, otherwise known as 1.125. And that'll give us our first line. So we'll start on the XY plane just because, and get a line from the origin, go straight up, and dimension tool, dimension that to 1.125. Great. Wonder if I can make these bigger in. Okay, well, I'll work on that later. Okay, so as per before, we need to figure out a sort of bottom edge of the peg of the cylinder, main pig cylinder. So we have that as our total height. We need this distance right here. We know that it's 1/4 inch all the way across. So it's going to be 1/4 inch once we revolve it, which means this distance that we need to draw is half of that. 0.25 divided by 2, or 0.125. 0.25/2. And that's the next part. So we've got our vertical axis and half of, or the radius of the peg part. We just need this vertical outside, which this vertical outside is, that's our 1 inch dimension. So this is 1 inch, which I could just draw right here. And so we need a line and snap it here, and dimension. And again, normally I would place the dimension out here, but because it's going to get busy here in a second, I'll put it over here, and that was 1 inch. Okay. And the last portion up here, we are going to make the part that looks like this first, and then the last part will be an arc. Okay. We know that there's this part here because it is flat on the top. Okay. This part here where it says 0.25 flat, that means the distance all the way across, we're going to put a horizontal line at the top so that when it revolves, it leaves a flat surface. We know that the flat surface needs to be 0.25 across, which means the short line that we need to draw attached to the top is half of 0.25. So let's get a line, and from the top of our tallest point, go horizontally, and we want it to be 0.25 across. So this is a half of that, 0.25/2. Okay, and so that sticks it out that way. Now we just need to figure out what the dimensions are here. Okay, this is what gets us out to the edge. And then once we get out to the edge, there's this little vertical face here, which has a tiny dimension. It's 0.031. And once we have that, then we can do our arc, which is this. Then there is a hex thing, but we'll deal with that in a second. Okay, so the line we need is this one, which, let me see how big that is. That one is half of, oh, okay. So it is 0.422 all the way across diameter. So that means the distance from the end point of this next line to the center is half of that. So we need another line that goes out this way. And this is the same thing. The dimension that we are given is the size of the bolt or the peg all the way across. And this dimension needs to be 0.422. So the distance we're interested in is from the end point of this line to the center axis, and that needs to be 0.422/2. Okay, horizontal dimensions are always halved because the part feature doubles them, so there's that. Okay, then we have, like I said, this little line here, which is going to be 0.031, and when that revolves, it's going to make that little vertical edge. So from here straight up, and dimension, we'll dimension this line 0.031, which is realistically 0.03125, but that's fine. 0.031, and like I said, this, when it revolves, will leave that flat vertical. And the only other dimension is the arc, which again has a spherical radius of 0.236. So that's what we're going to put in. Again, a 3-point arc, which is the default type. First click, second click, third click, slightly arced, but don't snap it to, you can see there, snap it to tangent. That's not what we want. I don't think that's a hard snap. I think, yes, it is a hard snap. Okay, so definitely don't do that. What's up? Which dimension? This one? 0.031. Okay, I botched it again. Circle, excuse me, arc, first click, second click, slightly arced in the correct direction, and that dimension is 0.236. Okay, so we are going to revolve it here. And just to give you an idea of what some options are, okay, there is this other part feature here, which says 45 degrees times 0.03, 0.236. 45 degrees times 0.03, which means that of our peg that goes like this, it's cut off at 45 degrees, 0.3 from the back. Okay, the way that I want you to do it, I'll show you first, and maybe I'll show you again afterwards, after I show you the other way. So the way I want you to do it is just finish sketch, revolve, center axis. That gives us the piece, the main piece, and we're going to use the chamfer tool. And the edge we want to chamfer is this one, and it's going to give us an issue. The dimension is how far in, which was 0.03. Okay, that was a chamfer as a part feature. Okay, we cut off the edge of a part. You can chamfer, and you don't need to do this. This is the other way. There is a chamfer tool that is it's underneath fillet. There is a chamfer tool that's for a sketch that you just choose the two lines you want to chamfer, and it breaks it. Like, this still works, but you can see how our sketch is all messed up like you can't change the other dimensions. Like what is this dimension? It's just a lot easier to do any sort of chamfering as a part feature. Okay, so once you have the sketch done at this point, revolve, choose your center axis to revolve around and hit OK. And then the chamfer, like I said, chamfer tool, the dimension is 0.03. We just need to choose the edge to chamfer, which is that one. Hit OK. And that is this part feature. The only other part feature is the threads, or are the threads, and this hex Allen wrench hole in the top. Okay, the hex hole in the top is a 6-sided polygon, like a hexagon, and the diameter they give us is 5/32 across flats, which means the distance, like essentially the diameter, if it were a circle, is 5/32, and the cut extrude is 0.111. Okay, in order to do a hexagon, it is just like a circle or anything, we need to be sketching. So we're going to start a sketch on this surface, and it is underneath rectangle. The options for rectangle will give you an option of a polygon. The default number of sides is 6, which is what we want. And then of inscribe and circumscribed, it doesn't really matter because we're not snapping it to anything. We're just making it about the right size, which is something like this. Don't snap it to anything that projects through, just something like that. And all those are the auto constraints, which you don't really need to look at. So you hit OK on the tool, and then still in sketch mode, the dimension we're interested in is the distance from one side of the polygon to the other. And that dimension is 0.25. No, wait, 5/32. This is 5/32. Okay, and that looks about right. And that is our polygon. We just need to finish sketch, extrude, choose our polygon, switch it to cut, and the cut depth is 0.111. Okay, and so there is most of it. The only other part feature, it's cut extrude. You gotta switch it to cut extrude, and the depth is 0.111. Yeah, take that one. Okay, the only other part feature for this one, and it'll be the last of the day, are these threads. And I'm not super concerned if you have the right thread standards or things like that, but it should look good. Let me finish this and then I'm on here. Okay, so you can get the thread tool and just choose the surface here, and it'll give you some thread. You can, there's a lot of it, 1/4 20 UNC, that looks right. Size is diameter 0.25. Is there another advanced properties? No. Depth. What does 0.75 give us? Hey, yeah, there you go. Okay, so 0.75 in the behavior thing will give you that offset. So it's thread tool, choose the edge, and in behavior or depth, oh wait, does offset do it? 0.25, but then no, we'll just put it in depth. And this one was at 0. What? No, wait, 0.75. Yeah, there we go. So it's 0.75 of thread. And even if you don't have like that offset, it's not critical, but I would like you to put some sort of thread on there. It looks better later on. But if you are interested in doing it exactly, thread tool, click on the edge, and the only thing you need to change is behavior, and that should be 0.75. Okay, if somehow you switch direction, it hit cancel and go again. And there you go. There is our axle peg. Great job, everybody. Okay, and again, save it. And save it as, please don't be anything doxy, train axle AXLE, because it's not a name. I'll be over in a second. AXEL, I believe is the name. And axle peg. Okay, and that is it for today. I'm going to end the recording and I'll come around and help whoever needs it. Okay, recording will be up shortly. Well, probably.